Hello, today we have a video on molecular structure and acid strength. So what we are going to talk about is how the molecular structure of an acid impacts its strength. So a lot of these rules you can reason through if you remember our list of our 7 strong acids and then think about, okay, which ones made the list of the 7 strong, what didn't, and then think about differences that they have. So, for example, we are going to start with our binary acids. So, our binary acids are something like HCl, where you just have the hydrogen ion and then a monatomic anion. So, HX or HCl, HBr, HF, their strength depends upon the strength of the bond and the electronegativity difference. So the stronger the bond, the weaker the acid. Because if we have a stronger bond, it's going to be harder to ionize. And we know that if we have less hydrogen ions in solution, it will be less acidic. So let's think about our group 17 halogens with hydrogen. So we know that HCl, HBr, HI all made the list of the 7 strong acids. HF did not. HF is not a strong acid because since fluorine is such a small atom, there's a greater attraction between hydrogen and fluorine. So therefore, it has a stronger bond. It's harder to ionize. Whereas HI is actually the strongest out of those 4. It has a weaker bond, therefore its proton is donated easier, so you're going to have more ions in solution. So for our binary acids, the strength actually increases moving down the group. Again, we can remember that because we know that HF, F is at the top of group 17, did not make the list of strong acids. All right, so the second factor that we can look at with our binary acids is moving across the period. So as we move across the period, an increase in electronegativity difference, so change in electronegativity, so an increase in electronegativity difference will give us a stronger acid. So if we take a look at our group 2 acids, we would have HF, which we know HF is not a strong acid, then water, and then H3. So we know that HF is a weak acid. We know that NH3 is a weak base and water should be neutral. So we can see that our acid strength increases moving across. And that's because our bond becomes more polar. So you're going to have the H plus donated a little bit easier. So for our binary acids, as we move down the group, our acid strength increases. And as we move across a period, the acid strength increases. All right, next we are going to talk about our oxyacids. So those are acids that contain OH groups or oxygen atoms bonded to a central atom. So something like sulfuric acid, which is H2SO4. Or nitric acid. So we've got our hydrogen ion and then our polyatomic ion, and our polyatomic ion has oxygen atoms. All right, so when we have the OH group on there, that bond will be more polar and more easy to ionize if Z is our central atom, if our central atom is highly electronegative, or as there are more oxygen atoms attached to our central atom. So if we look at these examples down here, we have phosphorus acid, which is H3PO3. We have phosphoric acid, which is H3PO4. And we have sulfuric acid, H2SO4. So we know that sulfuric acid has made the list of the 7 strong acids. Phosphoric acid has not. And the reason why is the S atom has a higher electronegativity than the P atom. So that leads to a greater ionization of the hydrogen atoms. Then our second factor here, the more oxygen atoms it has, the stronger it will be. So if we compare phosphorus versus phosphoric, we would predict that phosphoric would be a stronger acid because with those extra O's, it would be more polarizable. So this is here just reiterating what we said on the previous slide. For our oxyacids, if we're comparing things with the same number of oxygen atoms, their strength will increase if the central atom has a higher electronegativity. And that is because with a higher electronegativity on the central atom, it's going to allow the hydrogen ions to be donated easier. So if we think about our list of 7 strong acids, we have HCl, HBr, HI, H2SO4, HNO3, and then we also have HClO3, chlorate, and perchloric acid. But we also have acids like HBrO3, that would be a weak acid, but HClO3 is a strong acid. So your difference is the central atom, the bromine or the chlorine. Chlorine is going to have a higher electronegativity, therefore that will lead it to being stronger. It will donate the hydrogen ions easier. The same thing is shown here with hypochlorous acid and then the bromine and the iodine versions. So the HClO would be the strongest one out of there. And lastly, if our oxyacid has the same central atom, the strength is going to increase as the number of oxygen atoms increases. So if we think about it, HClO4, that made the list of strong acids. HClO3 also made the list of 7 strong acids, but the rest of the chlorate series did not. So we can see that as we have more oxygen atoms, our acid becomes stronger because it will donate the hydrogen ions easier. Another example of that is HNO3 nitric acid made the list of 7 strong acids, but HNO2 did not. So that would be nitrous acid. So we know that this one is stronger because it has the extra oxygen atoms.